Today we're at Wharton Point in Brunswick, constructing a demonstration living shoreline along an eroding edge of marsh here. Right behind me you can see our project site is only about 50 feet in length. We're using this as a demonstration because we have a lot of eroding marsh edges and eroding bluffs along the Maine coastline. We want to be able to demonstrate using some different techniques, some baskets made of synthetic fiber, and also these bags which are made of a coir fiber that are filled with oyster shell, that you can slow down erosion. And this is part of a larger project in New England that's funded by the National Oceanic Atmospheric Administration, and all 5 New England states are participating in the project. In Maine, we decided to demonstrate small, low-cost living shoreline treatments that could be transferable to other areas of Maine, whether it's an eroding marsh edge or an eroding coastal bluff. Living shorelines in New England are a relatively new thing, and they have not been used extensively in Maine at all. Nobody in Maine has used coir bags to bag oyster shell yet. We developed this bag design and went through several iterations with the supplier on that until we came up with a product we think we could use. This project, we're also beneficially be using a log, as you can see here, that's washed into place. This is an old log. We don't know how old it is, but it's pretty old. What you're looking at is on the right-hand side, you're looking at the baskets that are filled with oyster shell. And literally those are gabion baskets, basically made of this synthetic fiber. It's UV resistant. And they're literally filled with just buckets and wheelbarrows of oyster shell staked in place. To the left of that, you can see the log, and on top of that, we're testing these coir bags filled with oyster shell. And they're being staked right now, and they'll be twined so that they'll actually stay in place as well. One of the big concerns about living shorelines in Maine is, number one, we have really high tides. Number two, of course, we have storms. We have waves and things like that, but other places have that too. But in the winters, we're challenged by a lot of ice. There's 2-foot rafts of ice in this area that form. So we think the baskets will do really, really well in the ice. We don't know how well these bags will do, but we're testing that. The other thing that's happening here is working with the Casco Bay Estuary Partnership, we've developed a monitoring program in conjunction with the other 5 New England states that's being implemented throughout all the different projects in New England. And this living shoreline will be monitored for a period of 5 years. We're looking at things like what happens to the topography, what happens to the installations themselves in terms of the quality of them. Do they start falling apart? What do we need to do in maintenance in terms of that? What happens in terms of the vegetative communities above it and below it? Do we start seeing erosion in front of it? Do we see the marsh come back? What happens in terms of the critters? What kind of critters colonize this basket, for instance? Do we see oysters pop up there? Do we see mussels? Do we see something else? Do we see green crabs colonize everything and start decimating everything? All that's going to be monitored for a period of 5 years, so we understand a lot more about these living shorelines in Maine and New England. At our other site at McCoy Bay Conservation Lands, one of the ways that we have adapted our design is we have basically both of these 2 installations. But what we did is we took 10 to 12 foot logs, which are cut from trees in the area, and we positioned them perpendicular to the bank, so that the top of the tree is lashed into the mud at the top, and the bottom of the tree is lashed at the bottom into the mud. So if you have the bank, it's basically sitting like this. The idea with that, and they're spaced about every 5 feet. The idea with that is when the ice comes in, the logs can help protect the installation by breaking up the ice. So basically we're testing this site versus the other site in terms of how well they perform in the winter. We secure these on the top with something called duckbills. It's an anchor that's attached to a steel cable, and that's driven about 3 feet into the ground. And it's literally, as it sounds, you have a piece of rebar that fits into a hole, and you drive it in, and then you pull on this loop, and the duckbill goes like this and opens so that this doesn't pull out. And that has a 3,000 pound hold capacity. Then you attach these with lag bolts to the tree trunks at the top, and then as the tide fell, we positioned these in as best we could and then did the bottoms and drove duckbills on the bottoms. For the second half of the installation, we installed these coir bags that are filled with oyster shell, and then staked them and twined them down to hold them in place. So we have a biodegradable portion of the installation, about 25 feet, and then a synthetic portion of the installation. And then what we found is there was so much open space above these baskets that we put some additional bags above them to help keep horseshoe crabs from getting stuck behind the baskets. So it gives them more surface to crawl around on. You know, there's a lot of locations in Casco Bay where you've got fallen trees on a site, and you've got an eroding marsh edge or an eroding bluff. And we hope to demonstrate that the mix of these kind of techniques could be beneficial to slow coastal erosion so that you don't have to depend on throwing riprap down all the time. We also have another site in Yarmouth on Lanes Island. What's happening there is it's about a 10 to 12 foot eroding bluff that is shedding sediment so rapidly that it's actually covering the marsh in front of it. If you have an eroding bluff, the traditional approach is to regrade it to a more stable slope and then riprap the heck out of it above the high tide line. And you can do that with a relatively simple permit. But the problem is when you riprap, you are actually cutting off the supply of sediment from the bluff to the adjacent wetland and mudflat. We would not have these mudflats that we have in McCoy Bay if we didn't have erosion of adjacent coastal wetlands and erosion of adjacent bluffs. Okay, so it's a really, really interesting problem because if you stabilize the shoreline, you're cutting off the supply of sediment from the upland to the wetland. So the living shoreline is supposed to slow it down, but not cut it off completely. It maintains more of that natural continuity from the upland to the wetland. And the project in Lanes Island is all beneficial reuse of trees. So there's about 30, 35 down trees, which are literally lying on the mudflat or on the beach. They fell down from the bluff. So those are going to be cut. The bluff is going to be regraded to a more stable slope. And then that excess material is going to be used to build these kind of steps along with the logs. There'll be 3 steps that go up the face of the bluff. And each of those steps, the material is going to be placed in and that's going to be planted with native vegetation. So think American beach grass on the bottom, less salt tolerant as you go up, and then almost trees and shrubs as you get to the top. So you end up with an aesthetically pleasing project that did not require bringing in huge granite boulders to slow down the erosion. And that again is also going to be monitored for 5 years, and that's in conjunction with our partners at Maine Coast Heritage Trust.